everyone. So we are continuing our conversation about quadratic functions today. Really the focus of today's lesson is on the quadratic formula. But before we dive into the quadratic formula itself, I want to get some big picture stuff out of the way. So I've just jotted this on the back of the notes here. I don't know that you need to write this down. You are welcome to just follow along here. But just to remind you, this is what we've talked about with quadratics so far. There's two different forms that we can write quadratic equations in. We can write them in what's called vertex form, and we can write them in standard form. Now, the lesson that we did last class was focused on how to convert from standard form to vertex form. And that was with a process called completing the square. And then once we were in vertex form, we learned how to do a couple different things with vertex form. So for example, we can find the vertex because we know it's just h and k once it's written in that form of an equation. And then we can also find the zeros, or the roots, and we did that by plugging in a 0 for y. And then we solved. Okay, so that was the last lesson we did, was converting and then doing vertex and zeros. Our ultimate goal here is to make you a flexible problem solver. So I want you to be able to work with equations in this form, I want you to be able to work with equations in this form, and I want you to be able to switch back and forth if you feel like one thing would be easier in one form than the other, okay? We didn't really talk about converting from vertex form back to standard form, and that's because you already know how to do it. You would just have to simplify here. So you would do FOIL here. So you would do x minus h squared, okay, do all that distributing. Distribute the a, move the k to the other side, and your equation would end up looking like this, okay? So typically, you don't need a whole lot of guidance with that, and I don't know that you'll ever, I'll never make you do that process. But we do also want to make sure that you know how to do these things in standard form as well, okay? So that's what today's lesson is focused on, is how do you find the vertex and the zeros when we're already in standard form. And just so you can have it kind of all in the same place here, we're going to find the vertex with a formula for h. So there's a formula for finding this h value when you're written in standard form, and we'll talk more about that in just a minute. And then we use it to find k, and we'll talk about how to find k. All right. And then the zeros, this is really the big focus of the lesson. When you're written in standard form, you can find the zeros using the quadratic formula. So these two things are what we're talking about today. And yes, you already know how to find those things when you're in vertex form. We haven't talked about how to find them from standard form. So that's the priority today, okay? Ultimately, I mean, when it comes to like the SAT and stuff like that, it's not going to force you to go one way or another. So I want you to be good at all of these different methods, okay? For my class, we are going to take a quiz where you have to show me that you can do all of this and all of this and the conversion using completing the square. Okay, so ultimately you're going to have to know how to do all of these things, but you'll be able to choose which method you want in the long run. Okay, so let's go back to that quadratic formula, and hopefully this looks at least a little bit familiar to you from last year. You did cover this last year. And again, the quadratic formula is used to find the roots or the zeros of each function. So I'm in standard form here, which means I have a, b, and c values sitting here for me. And then I should be able to plug those into the quadratic formula. You do need to know the quadratic formula, okay? You do need to have it memorized. Hopefully once you use it a few times, it'll kind of, lodge in your brain, but you will need to know it. So it starts with negative b. If my b is already negative, I'm going to put it in as a positive 3 plus or minus square root of... when I go to do b squared, make sure that you put that negative 3 in parentheses before you square it. That's probably number one mistake right here. Minus 4 times my a value of 2 times my c value of negative 5, all over 2 times 2. Okay. I would recommend that you start with this calculation, the number that's under the square root, but without the square root. And there's a reason I'm telling you to do that. That number there has some significance that we'll be talking about more later this year. You did learn it last year also. But so I would plug in negative 3 squared minus 4 times 2 times negative 5. And notice I did put that negative 3 in parentheses. I end up with 49. So now I can rewrite as 3 plus or minus square root of 49 over 4. Okay, I've made a really big deal about remembering that when you take a square root, you have a positive or a negative answer. The good news here is that's built into your equation for you. The plus or minus is there for you. That does mean that I'm going to split right here and come up with 2 different answers, which should make sense. Your roots, you should have 2 of them. So 3 plus 7 over 4 and 3 minus 7 over 4. And so my roots for this first function would be 10 over 4, which is 2.5, and negative 4 over 4, which is negative 1. Now, I just did those in my head, and I recommend you do that whenever possible because typically your brain makes less mistakes with these than your calculator does. But if you were going to try to put that into your calculator, remember to put that top part in parentheses or do it in 2 steps. So if you want to do it all at once, I would type it in as 3 plus 7, close your parentheses, divided by 4, okay, to get the 2.5, or 3 plus 7, hit enter. I hope you wouldn't need a calculator to do that, and then hit divided by 4, okay? Okay, let's start the next one. So negative b, so I'm going to go positive 7, plus or minus the square root of negative 7 squared minus 4 times 2 times negative 3 all over 2 times 2. I'm, again, starting with just that calculation right under the square root there. And so I'm going to go negative 7 squared minus 4 times 2 times negative 3, and I get 73. Now I can tell just from looking at that number that this one's going to come out uglier because 73 is not a nice perfect square like 49 was. That's okay. You are going to get answers sometimes that are irrational, and sometimes it'll call for an exact answer, in which case we would leave this square root alone, but I'm going to go ahead and make it into a decimal. So I'm going to do the square root of 73, and I get this long decimal here. All right, so I'm just going to say 7 plus 8 point, I think we could round to 2 decimal places and feel good about it, over 4, and then 7 minus 8.54 over 4. This time when I write my answer, because I know I rounded those decimals, let's see, I'm going to add 7 and divide by 4. I'm going to write my answer as an approximation because I know that I rounded here. So after I divided by 4, this is what I came out with, 3.886. So I'm going to say x is approximately 3.89, or 7 minus 8.54 divided by 4 is negative 0.385. Okay. And we could, just like we did before, we could go ahead and check on like a Desmos graph or on your calculator and just make sure that the zeros are in the right place here. Sorry, it's not giving me my window here. So if I type in that first equation, 2x squared minus 3x minus 5, notice I have roots at negative 1 and 2.5, which are the exact places that I found in example 1. Okay, I'm going to turn that one off and type in the second one. So 2x squared minus 7x minus 3. And I've got a 0 at 3.886, so that's what I called 3.89. And then negative 0.386. I think we got 385. Discrepancy there is just from having rounded that decimal in the step before. So perfectly good with me. Okay, so now let's launch into, whoops, close all that. finding the vertex. So we just found the zeros for both of those functions. Now this question is asking me to go back and find the vertex. So there's a way to find the vertex without converting to vertex form. Of course, that's always an option, right? We could convert to vertex form. But we have this formula, and I actually wish instead of saying x equals, this said h equals, because it's not just any x here, it's specifically from the vertex. Remember, vertex is h and k. The x value at the vertex is always equivalent to negative b over 2a. And if you look in quadratic formula, there's actually a piece of the quadratic formula that this is related to. Okay, so for the first example, I'm going to start with h equals negative b over 2a. So that would be negative 3, which is positive 3, over 2 times my a value, which is 2. That's going to be 3 over 4, which is 0.75. Okay, so that's the h. Now I need the k. There is not a formula for k, not a specific formula. But we know that k is the y value that goes along with this x value. And anytime you have an x value, you can find the y value by plugging into the equation. So that's exactly what we're going to do. We're going to take this 0.75 and just plug it into the equation we're working with for x, and that'll give me the y value that goes along with it. So for k, I'm going to go 2 times 0.75 squared minus 3 times 0.75 minus 5. Strongly recommend a calculator here. 2 times 0.75 squared minus 3 times 0.75 minus 5. And I end up with negative 6.125. So I would write my answer then with these two numbers as a coordinate. So my vertex here would be 0.75 and negative 6.125. Let's take a look at that graph we did just a second ago and see if that lines up with what we found. Let's see here. So that was this first graph. I'm going to move it so I can see the vertex. And down here at the bottom, we have 0.75 and negative 6.125. So right there, you should have your answer. Okay. You may want to pause the video right now and give the second one a try. Why don't you try finding h and k on your own? So in this one, negative b would be positive 7 over 2 times my a value of 2. 7 over 4 is going to be 1.75 for h. And then remember, we're going to find our k value by plugging this into the equation itself. So I'm going to go k equals 2 times 1.75 squared minus 7 times 1.75 minus 3. And I end up with negative 9.125. So my vertex would be 1.75, negative 9.125. Let's check on our graph. That's this one. My vertex is down here. And I ended up with 1.75 and negative 9.125. So yeah, that looks good. If you don't have a graphing tool handy, you don't have Desmos, you don't have your calculator, maybe your calculator is hard to read, another way to check is your vertex should always be located halfway between your two zeros. So halfway between negative 1 and 2.5 would be 0.75, okay? Halfway between 3.89 and negative 0.38 would be 1.75. So that x value is always going to be located exactly halfway between these two. That's how you can kind of keep an eye on it and make sure your answers make sense. Okay, so that's it for today. Today you are going to finish up the quadratic formula stuff. There's a worksheet that looks very similar to the one you did with completing the square. That's because it's pretty much exactly the same. Your answers are all going to come out the same for the vertex and the zeros. The goal is to try out a new way of doing this problem, okay, using a new method. So I'd like you to try those problems using the quadratic formula and using the h and k, and then you can use your old worksheet to kind of cross-check and make sure you're getting the right answers. Okay, all right, let me know if you have questions, and I will talk to you soon.